Okay, Steve, can you flip the light switch down for us, please? What questions do we have? Yay, happy Wednesday, I'll take that.
On page 149,
Page 149, which one?
number 6. There's like two different variables, and I'm like, what the frick am I supposed to do?
Oh, you had to make them both X. All right. So number 6.
You can just do that?
It was a type error that we had done. So this was an error right here. So I imagine you could just change it to this. Oops, wait. I don't know why I'm making that a 3. It should be a 2.
Come on, Mr. Stroke, you got this.
Thanks, man. And then I'm going to subtract 5, bring it over. Is that all right?
Yuppers.
Okay. So there was an error on that. It's just a type error. So I won't give you two variables to try and solve like this. So my A value is 2. My B value is -3. And my C value is -5. Remember, you got to make it equal to 0, so you got to move everything over. And we know this. Ram is tone deaf, isn't he?
I got this song down.
Yeah.
Can you factor that?
You got the
though,
word
so,
right.
like, -5 times 2x squared?
Will it factor?
Andrew, I'll give it to you.
No.
It might.
2 and 5.
Yeah, it probably is factorable, which means when we do, bless you, when we do the quadratic formula on it, would mean this becomes a perfect square. Okay? So sometimes you can go through and say, should I factor it? And sometimes it might factor, sometimes it won't. My thing is, if you can look at this real quick and say, hey, you know what? Yeah, that's -10 is my magic number. I need alternating signs, and I got 1 and 10, 2 and 5. Which ones would work to give me -3x?
2 and 5.
Yeah, so that has to be the negative and positive, right? So you could easily do it this way if you wanted to, and it'd totally factor.
So, if we,
I couldn't have said it any more clear there.
Wait,
so if we're able to factor it, we should just go ahead and factor it.
Right?
We just get wrong, man.
So, yes, if you can factor it, factor it. But if you're like, you know what, I like this quadratic because it's going to work every time, do it. So let's see, that's going to be x equals 5/2. Okay, so if you would have gone through the quadratic formula, a few things would have happened on this problem. This right here would have been a perfect square. I mean, just take a look at it. B squared is 9. Okay, and I'm just doing underneath here is all I'm looking at. I'm just looking at underneath here. I'm looking at this part right here. I'm not looking at anything else. I'm just looking at that part. So 9 minus 4ac. So 9 plus, so that's 8, that's 40. So that's 49. So what's the square root of 49? 7. So this works right there. That's how you know, if you got to this point on this problem, you're like, oh my gosh, that's a perfect square. It would have factored. Okay? Which way's the right way to do it? Both. It's your choice. Yeah.
What would it look like if you have to solve for 2?
Oh, we're not even there. Blush. The question was, what would it look like if you had to solve for 2 variables? The one that you'll see one day in the distant future would be like this. This is the, oops. This would be the equation of a circle. Okay, so what you basically do is you get this, you realize that this so this would be a circle with center -2, -3 with a radius of square root of 19. That's what it is. That'll be the first time you'll see that kind of thing. I skipped a major step between there. Because I see it. I know how to do it real quick.
Show us that major step.
So you complete the square right here. So you go x. This becomes x squared plus 4x plus 4. This becomes y squared plus 6y plus 9. That's where the 9 came from. That's where the 4 came from. If I factor this, it becomes this. If I factor this, it becomes this. That's all it is. It should be pretty straightforward. Yeah. All right. What other questions did you maybe come across on the problem? Number 9, the 5x minus 8 one. Okay. So problem number 9. Okay. 2 ways I can make this equal to 0. I can subtract 2x squared and bring it over here. So it would give me this. Or another way to look at this is you can bring everything over to get this. So what do you notice about the signs between the two sides? Yeah, I have a positive and a negative. Then this becomes opposite sign. Everything's opposite sign. The opposite signs will work out very well with the quadratic formula. It will allow you to get the exact same answer because of how you're multiplying the variables together. Okay? So, yeah, it'll get you the same answer both ways. So let's just focus on this part. So A equals -2, B equals 5, C equals -8. Tone deaf boy back there, want to sing it?
Why are you inverting? B squared minus 4ac all over 2a.
What the heck?
Oh, I wasn't even like
Thank you.
close.
That
That wasn't
wasn't
like
good.
that wasn't like anywhere near like the way the song
No,
went.
you're-
It was
of
just
course.
like,
You only got the all over to it.
Hey Rom, are you in the choir?
No.
Good.
Dude.
One, two, three, go
This
solo
dude didn't
one.
have the rhythm right. He had nothing right.
I know. Actually, like,
It's like get a count going. So Rom's like, find the rhythm. It's this.
X equals negative b over 2 x squared. That's what he be like.
I'm just kidding, Rom. Give me a hard time. Love you to death, man.
All over
All
2
right.
All over to
All over 2
all over the
All over 2. All right.
Hey, what is this answer? If this is negative, 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 what's this going to be here?
Negative.
There you go. Let's see. 864, right?
That's the
Perfect square.
Is that right?
39.
Did I do that right or wrong?
Wait, I have a question.
Yeah.
So
Shh.
since those are both perfect squares, can you just unsquare them and get rid of the like square root sign? So that it's like -5 plus or minus.
Oh, I see what you're saying.
-8.
You have to combine underneath first.
But they're perfect.
You are absolutely correct. But unfortunately, you have to do the order of operations first. You have to do what's inside grouped before you do the
So then
radical.
this would factor.
So this becomes 25 minus 64, which is negative.
Something. Could you factor that?
Is it
though?
negative 49?
Sure.
Is it?
Can't factor this out.
It is.
Is it? Okay.
Unless it's
So,
Negative 30.
a negative 39? What did I say happens when you have a negative under the radical? What magical
I
event?
gotta make it positive.
There, and I happen to.
Oh, I forgot
We
that.
replace
I
this.
think irrational.
So it's not irrational. It's not real.
Wait, so then why is it I?
Wait, if it's not real, how does it exist?
Irrational.
The name of the number system is called the real number system. It's like calling a Ford a Ford. It's the name of it. Okay? That's so when we say it's not a real solution, it'd be like saying it's not a Ford.
Ron's like, why is it not real?
Or
Does it not, it's
Why
not,
does
it's
it
not
not
fake. They,
exist? Does it not exist?
some person way back when they were designing number systems was like, let's call it real. This will mess up people, and then they'll get students from here on out to say, is there a fake one then? No. Let's see. 39 breaks down to 3 and 13, so there's no perfect squares there. So this is my answer right here.
Right there.
What is what does this mean as far as if I had graphed it? What would it have done with the x and y axis? What relate?
Irrational. Be not real.
It's not real. It's not one of the real numbers. So where does it not cross?
The x-axis.
The x-axis. It will always cross the y-axis. In fact, it'll cross the y-axis at 0, -8, but it won't cross the x-axis on this one. We good? Can I move on?
Yes.
Any other questions we might have come across?
Actually, I think we're good. I think we're Versace.
We're Gucci.
Gucci.
Is this lane?
He said we're Versace.
We're Coach.
See what I did there?
Oh.
All right. So I have a little math situation I wanted to talk to y'all about, and it deals with quadratic. Okay. So if you want, you just kind of watch. So
She named one of the characters Avenue. Ow. Do you want us to turn this in?
no, I already put points in.
Are we gonna do the backside of it tonight?
All right.
I just need to know if I need to keep.
Hang on, just watch. Okay. So let's just do a little cross-curricular for a moment. Distance equals 1/2 AT squared. Okay? So this is how an object, if an object were to fall off of a cliff or a building or any level, you can figure out how far the distance is by using this formula. Okay, so sorry if a couple of you are being rude. All right, so A stands for the acceleration of gravity. Acceleration of gravity is negative 9.8 meters per second squared. That's in meters per second. Or it's negative 22 feet per second squared, this is more the American version that we prefer because we don't really deal with meters in America because we think we're better than everybody else. And then we sit there and say, gosh, why do they have this figured out and we don't? Because they're using the metric system, which is all based on a factor of 10, which means you either multiply or divide by a factor of 10, which is really easy. Unfortunately, we in America are too dumb in the head to think that we should switch. All right, so this right here, this is how this works. I want to show you. What do you think D would stand for? Distance. Everyone okay with that? And I want to show you why this does work. Okay? So T would stand for what? Time. And time is what right now in this problem?
Seconds.
It's in seconds. How do we know? Because we have it here.
I thought it was 9.8.
Yeah, I don't know if it's negative.
It's negative because it's falling towards the earth. I guarantee it's negative.
You guys, why are you just gonna
Wait, doesn't that come out as a negative distance?
No.
It's falling
So if something's falling towards a planet, it's a negative. If it's going away from it, it's positive. Okay? So, I want to show you why this works. Distance, if we use this right here, our distance will be in what units? Feet. Does everyone agree? So why does this type of problem work? Well, distance, we're going to say that this answer should be in feet, is equal to 1/2. 1/2 is called a constant. It's always going to be that way. A, we're going to put in this place as negative 22 feet per second squared is equal to time squared. Time in this case, time is in seconds, but what is time being done up there? That's squared, then that has to be squared. So what I want you to think about is, this is on the bottom, This is on the top. So this would reduce here and here. What would that allow our units to be in when we're done?
Just feet.
It's just in feet, okay? So, when I was 16, for some odd reason, I was a trusted friend. And a lot of my friends' parents trusted me, and I'm not sure what I did in order to gain that trust, other than I knew how to back up a boat when it was attached to a vehicle.
Oh my god.
I mean, seriously. Like, I had friends' parents that would come, hey, Chris, can you back our boat into the garage? Oh, yeah. And I could do it. I could do it quickly, and I could do it perfectly, and I could put it right there. So for some odd reason, I became this trusted individual. So when at age 16, there were times where it'd be like, hey, we have a boat, or other people have boats, and we used to go to Apache Lake. Apache Lake in Arizona is one of the lakes that's dammed up on the Salt River. It's a reservoir, but they call them lakes in Arizona. Here they call them reservoirs. I don't know why. Difference between two states. Apache Lake had, and I might have told you all this, but it had cliffs. And the cliffs,
The 2-screen one?
yeah. So this had a rock on top, and then there was like this ledge here. So if you jumped off this ledge, it was pretty quick. Okay? If you jumped off here, it took a little while longer. And if you jumped off here, that was the 2-screamer. Okay? So I want you to think about what a 2-screamer would mean is if you were going, I mean, it was literally like that, and then you hit. Okay? So how this equation works, being that this is squared, it's a parabola. Okay, so how does this parabola work? Works a couple of ways. It looks like this as a parabola. Only a portion of it is used. We only use this portion of it. Why? Because this portion means I'm falling into the rock, which is a whole different story. So think about what this really meant. How long would a 2-screamer go? I mean, it'd be like, maybe 2.5 seconds. Okay. So think about 2.5 seconds fall. Think about it. Like if you were to jump, it would be ready, set, jump. Hit. Long time to think about?
No. Kind of.
Kinda.
Not really.
It's enough time that you start thinking, oh boy. Or I over-rotated, my face is going to hit first.
Oh, gosh.
Okay? So it was funny because you'd always get someone who had some sort of physics that they'd talk about. Oh, if you do a flip, your rotational inertia is going to create it to be longer. No, it's the same amount of time. It has to do with the whole concept of if you were to shoot a gun horizontal to the ground, not at somebody, but at in a direction, the immediate force acting upon that bullet that's constant is gravity. So if you had a bullet and a gun and you went bang and you dropped the bullet at the same time, both bullets hit the ground at the same time. One hits the ground way out that way, this one hits at your feet, but the acting force on it, and people are like, oh, what about wind resistance? It's accountable. Okay, wind resistance is a horizontal distance. It's not a vertical distance. Okay, so they hit the ground at the same time. So, I mean, honestly, if you did this math, if you wanted to truly figure out how far this was, I mean, it's this equation. And this is a quadratic. Okay, we're using negative 22 feet per second squared. And then 2.5 seconds, if I go 2.5 and square it, well, 25 squared is 625. 2.5 squared is 6.25 seconds, that's squared, seconds squared. So what happens is my units cancel out here and here, leaving my answer in feet. So then I go, oh, well, 2 goes into negative 22. That's negative 11. And then if you go, your answer is going to be negative, okay, because you're falling towards it. So you think about your distance, how it works. You fell from a higher distance to a lower distance. So what does that come out? 6, 8, 7, 5, 2 decimals. 8. Can somebody multiply that real quick? 11 times 6.25. Tell me if I got it right. Anyone got a calculator? Did I get it right? 11 times 6.25. Cool. So, how far is that? How far is that? How tall is the ceiling? Anyone know?
8 feet. 7 feet.
Okay, I'm
Just
fi-
like 7 feet.
I'm 5'9".
It's like 8 feet.
If I put my hand up, how high is my hand? Maybe to 7 feet. So is that maybe an 8-foot ceiling?
Maybe. No, it's like 8 feet. Like
Maybe an 8-foot ceiling.
Yeah.
So 68. That's an. If this ceiling here is 8 feet.
I said 60 more feet above.
Yeah, I mean, think about it. You were talking about, go to the top of our clock tower. We were probably jumping from higher than that up
On
to
Apache Lake.
get to the lake. Huh?
On Apache Lake.
On Apache Lake in Arizona.
It's like 22.
Yeah, it was ridiculous. It was one of those where, if you think about how the surface tension of water works, it was really a bad move on our part. Because the surface tension of water, if it's not being disturbed, has the consistency of cement. Meaning, you're going to hit it, stop instantaneously, and then go in. So if you stop, if you did like a belly flop, all the organs in your body are going to be going as fast as you're going when you hit, come to an instant halt. Your heart, I don't know if you know about this, but your heart is basically slightly left of center in your chest, okay? And it's kind of dangling like this, and it's doing this. It's going to move back and forth as you move, but it does this as your wrist. So if you hit something quick enough, you get a major aortic tear, which means your heart will pump about 4 more times, fill your body cavity with the blood that it pumped, and you're going to expire. You're going to die. Okay? So think about that. If you did a belly flop into the lake at that distance, your heart is going to do this. Slam. It's going to rip the aortic arch, which basically goes up and then comes straight down, goes down to your body. So that's going to take place. That's the kind of speed that we were hitting that water at. I mean, it was fast. And there were definitely times where you would hit you wanted to make sure your feet were toes pointed in. You wanted to become as streamlined as possible as you entered that water. Why is that? Because if you're a flat foot, your bottoms of your feet are going to slap the lake, and it's going to hurt. If the guys jumped and decided not to keep their legs closed, it's not a good idea. Okay? It's now what always amazed me was there was people that would do flips off of this. And it always amazed me going, how do you know?
You're going to land on your feet.
Yeah. But I remember there was people, they would dive off of it. And they would enter the water, make sure their hands were here to break the water. But you're going so fast that the water's not breaking fast enough that you smack your head pretty hard. I mean, it's not a good thing.
That's why you shoot a bomb at
So let's do this. Let's do this. Let's play a little bit more with math with this. Okay? We traveled 68.75 feet in 2.5 seconds.
Dang.
Okay? So let's do this little bit of math. Now I'm going to ignore the negative because I'm not concerned about it right now. We're talking about, so I am traveling at 68.75 feet in 2.5 seconds. Okay? Does that make sense? But that doesn't mean too much to us because it's like, so what? So let's convert this to miles per hour.
Oh gosh.
Okay? Now, it's not a hard thing to do, and if you need a calculator, it would really be helpful if you had a calculator to help me on this because I can't do this all. Okay? There's calculators in the cabinet. I'll wait if you want to get one, and I will talk you through how to get this, but we are going to figure out how many miles per hour we were traveling, and this is called dimensional
Should
analysis.
we try doing this on our own?
Yeah. So we're gonna go walk through it real slow and just talk through it. But again, this is all related to a quadratic formula. Okay, so we've been working with this, so this is a real life application of it. And this, something in miles per hour is going to mean a lot more to you than something that is in feet per second. Okay, so what would you like to convert first? Would you like to convert feet into miles or seconds into hours? It doesn't matter. Feet into what?
Miles.
Feet into miles. Okay, so let's do feet into miles. So 68.75 feet over 2.5 seconds. Okay, so I want my new units to be in miles per second, right? Okay, so let's think about this. If I wanted to eliminate feet, if I wanted to cross off feet because it's a fraction, should feet be on top here and bottom here, or should it be on top and top?
Top and bottom.
Top and bottom, okay? So, I know that 1 mile is how many feet? 5,280. Okay, so if we were to do this math right now, feet and feet cancel out, what would that have my units in now?
Miles per second.
Miles per second. Okay, so now I want to convert my seconds. Okay, I want to convert my seconds. So I know that there are 60 seconds in one what? 1 minute.
And 60 minutes in an hour.
And there's what?
60 minutes in an hour.
60 minutes in 1 hour. Okay? So, I want you to see what's going on here. I have minute down here, minute right here. They cancel each other out. Notice the numbers are still there. I'm not reducing anything. Okay? And then I have seconds right here. Do I have seconds downstairs anywhere?
Right there.
Yeah, in the very beginning. So now, what will my units be? What will my units on top be? Miles. What will my units on bottom be? So if we do this math correctly, we are going to get miles per hour. Okay? All right, so, ready? So this is where a lot of students, they want to make it so difficult. Don't. Let's multiply all the way across. If you have a calculator, go 68.75 times 1 times 60 times 60 and tell me what you get. So again, that's 68.75 times 1 times 60 times 60. That's how much? 247,000 what? 500. Okay? And that was in miles. But then I'm going to go 2.5 times 5280 times 1 times 1. So it becomes 2.5 times 5,280. 13,000 what? 200. And that's in hours. So what this means is I would travel 247,500 miles in 13,200 hours. Wow, that's fast. Wait, that means nothing to me because I can't even
Divide it.
Yeah. So
I know.
So does everyone agree that my answer will be in miles per hour?
Yes.
Okay. So what should I do with this part?
Divide it out.
divided. So go 247,500 divided by 13,200. What'd you get?
18.75.
How much?
18.75.
18.75 miles per hour.
Like,
Okay. So think about this. Think about it. Is 18.75 miles per hour fast?
Yeah.
So I want you to think about how fast it would be. Now, is that fast on the freeway? No. That's the guy on the freeway. You're going, dude, what's up with you? And you know, by the time you get done saying that, you're already a mile ahead of him.
We don't know this. We don't drive
Okay. So think about this. Think about this. The posted speed limit out in front of the school when it's not a flashing school zone is 30 miles an hour. Now let's assume people are abiding by the speed limit at all times there. I know they're not. So roughly half the speed they're going. So 15 miles an hour. So think about this. Does anyone know how fast a person normally would walk? If you have your phone, Google it.
It's like 2 miles.
2 miles an hour. Google how fast a person could run.
Depends on the person.
How much?
What's the average?
15:10.
So Google it. So someone asks Siri, how fast can the average person run?
Maybe like
How fast can the
Okay,
average person?
walking is 3.1 miles
Siri, hey.
3 miles per hour.
28 miles per hour. So that's 28 miles per hour is like the fastest the average person can run.
great.
Oh man, it's Johnny. Yeah, baby.
How are you?
Oh, I'm doing good. You guys know Johnny?
Oh,
I love this.
Dude, best dude ever.
I love this kid. Oh.
I just went to your office, so I was like, less 310.
Yeah, baby, man, you found it.
I
Oh,
went over to the. Whatever that place is.
how's up? Oh, you went over to my CTE?
Did we miss them?
You could just
And
say
what happened?
constructive.
Dude, I had Johnny. Wait, when did you graduate? 2 years? Last year? Last year.
Last year.
Yeah, baby. How's Auburn?
Good. It's a good time.
Auburn boy. SEC, man.
SEC, man.
Hey, Mr. Stacks back there, freshman running back for varsity, buddy. Yeah, you might see him in the SEC. You might see him.
Are we talking about some orange stories here?
Nah, I talked about that yesterday. At least with geometry. Yeah.
This is algebra.
Yeah, you didn't get it. Hang on for a little bit. We were just talking about.
Oh, yeah.
Sweet, man. So, 18.75 miles per hour. The average person could probably run up to 28 miles per hour. That means in 1 hour time, if they were able to maintain 28 miles per hour, they're going to run 28 miles. So, this is a little bit slower than the fastest a person could run. But think about this. You are at full speed, and you run into a wall.
I did that before.
Nope.
Stacks. Boom. You have that pitch. You are at full speed, and you find that 310-pound lineman that stops you.
That's a
You didn't run over.
All right. Okay.
Oh man, it's good stuff. All right. So I wanted you all to see a real life application.
That's so funny.
I wanted you all to see a real life application with these. All right. So let's do this for tomorrow, which is Thursday.
Mañana.
Mañana.
That would be when the sun will come out.
May 26th.
Gotta wait till December. Pasado mañana.
To be fair. So I'm cutting business on the first day. 3 days later, and I was the first day the pool opened. So like,
Cinco.
I mean, I'm still gonna get hands. If you can't keep your legs that high, you're done.
All right. You guys got 10 minutes. 10 minutes. 10 minutes to get a start on that. Good?